Alright guys, I'm going to take a look at problem number 4 and problem number 6 from off of the practice sheet we've been looking at for the last couple days on graphing the step functions. And in number 4, I just copied this right off of the practice page. I have a ceiling function, right, because I have the marks at the top but not the marks at the bottom. I have a ceiling function with an x plus 2 inside. And the way that we're looking at graphing these is to make a table of values. And the values I always like to toss into my table are 0, 1, and 2. They're nice numbers, they're easy to work with. So I'm going to put 0 in place of this x. I'm going to add 2. Inside of this I'll have a 2. And then the ceiling of 2, well, it doesn't have to be bumped up to anything. 2 is already a nice number. So I'm going to have a point on my graph at 0, 2. So I'm going to have that point on this graph. I'm going to put 1 in place of x, add 2, get 3. The ceiling of 3, well, 3 doesn't have to be bumped up to anything. It's already a nice value. It's already an integer. So that's just going to give me a 3. So I have the point 1, 3 on my graph. And then the last value I want to plug in is going to be 2. And if I put 2 here and add 2, I get 4. The ceiling of 4 is still 4 because 4 is already an integer. So I have the point 2, 4 that also has to be on my graph. Now when you're graphing one of these step functions by making the table like we are here, once you see a few different steps starting to take shape, like we have a step at this y value, another step at this y value, and we're going to have another step at this y value. Once you realize you're on a few different y values, now you want to start to try to find where that pattern is. So I'm going to focus on trying to figure out when I go from this step to this step. What x values are going to keep me with a y value of 2? What x values are going to leave me with a y value of 3? So let's see. I'm going to go back into this table. I'm going to try a number like 1/2. Alright? So if I put 1/2 in place of this x, and then I add 2, I get 2.5. And then the ceiling function will cause 2.5 to move up to 3. So I realize the point 1/2, 3 is going to be on this graph. And similarly, if I take a point in between 1 and 2, a value like 3/2, and put it here, 3/2 is 1.5. If you add 2 to that, you get 3.5. And then the ceiling of 3.5 is going to be 4. We're going to bump that up to 4. So I'd have the point 3/2 or 1.5, 4 also end up getting plotted. So now you can start to really see where these steps are located. So this step must extend backwards. Does it extend backward clear to just above where this point is? So that's the next question. Well, what x value would be just in front of this open circle? That'd be an x value like maybe 1/10. If you take 1/10 and put it here and add 2, you get 2 and 1/10. What's the ceiling of 2 and 1/10 or 2.1? Well, that's going to move you upward to 3. So yeah, that will leave you at this y value. So our first step is going to be here. Notice how it's 1 unit long. It goes from the x value of 0 with an open circle at 0 to an x value of 1 with a closed circle at 1. 1 unit long. We have a jump of 1. This step is going to be 1 unit long. It's going to have open circle on the left, closed circle on the right, closed on the right, open on the left, 1 unit long. Once you see the pattern form, you can just go ahead and draw in the rest of your steps. So all of your steps are going to be 1 unit long, and actually I goofed that one, because if you notice what I did was I jumped by 1, I jumped by 1. Here I actually dropped down 2. I should have dropped to this y value, and this step should have been looking like this rather than what I drew there initially. So this was wrong, and that's why I guess you shouldn't do your math in pen like I'm doing right now. But you want to build a table. Once you see a few different y values in the coordinate plane, try to carefully think about where your steps are going to be. When do you move from one step to the next? Where's your open circle going to be? Where's your closed circle going to be? If you can determine where they are for one step, just use that pattern to draw in the rest of your steps. We'll also take a look at number 6 from off of that sheet. And if you take this function, which is a floor function, right? We have the marks at the bottom but not at the top. I have 1/3 x inside this floor function. I'm going to pick these values, and I actually went to a third value here, but I would have started with 0, 1, and 2. And if I put a 0 here, times 1/3, it's still a 0. What's the floor of 0? Well, 0 is already nice. It's 0, 0. So 0, 0 is going to be on this graph. If I take a 1 and put it here, 1/3 times 1 gives me 1/3. What's the floor of 1/3? Well, it's going to get knocked down to 0. If I put a 2 here, 1/3 times 2 is going to be 2/3. What's the floor of 2/3? Well, that's still going to knock me down to 0. And if I take 3 and put it here, 1/3 times 3 would give me 1. What's the floor of 1? Well, it is 1. So I finally see a new y value. I'm going to have 0, 0, 1, 0, and 2, 0, all on the same step. Notice these are all on the same y value. I didn't move up or down in the coordinate plane yet. And now I get to this third one, or this fourth one actually, this fourth ordered pair where x was 3. I get 3, 1 out of it. So 3, 1 would take me to there. What I want to try to figure out is when I go from this step here to this step here with a y value of 1. I want to go back and think about what happened when we put 3 into this. When we put 3 in place of this x and multiplied by 1/3, we got 1. The floor of 1 is 1. It doesn't change at all. 1 is the first number that you can have that would give you a floor of 1. When we put 3 in place of this x, 1/3 times 3 got us 1. Floor of 1 is still 1. This is the first x value that will get you onto this step. If you don't believe it, try this. Try 2.9. Take a number like 2.9. So I know my table's not in numerical order anymore, but that's okay. If you take 2.9 and you put it in place of x and check on a calculator what 2.9 times 1/3 is, you should get a number that's very, very close to 1, but a little bit beneath 1. It's going to be 0.9 something. And if you take the floor of 0.9, it's going to drop you down to 0. And that just kind of confirms that this step right here where y is 0 is going to extend clear over to just below this open circle. So the length of my step now is 1 unit, 2 units, 3 units, and then I jump up 1. So I'd have 1 unit, 2 units, 3 units, open circle, jump up 1, 1 unit, 2 units, 3 units, open circle, jump up 1. If I want to draw one going back this direction, I'd have an open circle on that edge, 1 unit, 2 units, 3 units, close circle, drop down 1, open circle, 1 units, 2 units, 3 units, close circle, and that would be a rough sketch of this step function. So hopefully you can use these examples to help you do some more of those problems, either over the weekend or on Monday in class. Feel free to respond to the type 1 that I'm going to put on Moodle here to earn yourself a little bit of bonus on this over the weekend. Thanks, and I'll see you guys on Monday.